Hello mates, in the previous video we started talking about the celestial sphere and we just discussed what the celestial sphere is, and we said in this video we are now going to start the systems, the celestial systems or the coordinate systems under the celestial section. So let's start with the vertical system. The vertical system, basically what this is imagine imagine this is a string, and then you tie a weight or a stone to the end of this string, and then you just let the stone go. This string will move about like this, but then it will then rest. It will rest vertically. It will rest in a vertical position. So imagine this is you holding this string, and then this is the stone. And then that's you holding the stone. So now this thing is called this thing that you would have created when you tie a stone to a string is called a plumb line. So here the plumb line, when it's at rest, is directed along the pull of gravity, because definitely there is going to be weight here. So the gravity is going to pull the stone, and then it will be vertical like this. That is, so it is along the radius of the center of the earth, because the earth let me just make this person a giant and put the earth like this. It will be directed along the radius of the earth like this. When the earth is large, then definitely it will be straight along the radius of the earth. This line extended in both ways is known as the vertical. So when you extend this line upwards, going all the way up to the celestial sphere, which is somewhere up somewhere above this girl, and going all the way down. So when you extend it like this, when you extend this line, this vertical line, you're going to come up with something called the vertical. So this is called the vertical. So what is called? It's called. Let me try and erase this earth this circle that I put to represent earth that she's standing on. Okay, so when you extend it, even going down like that vertically, you come up with something called the vertical. So this is called the vertical. Okay, cool. And then now in this system, it is a convenient axis of the celestial sphere. We are going to call it, this is going to be now our axis of the celestial sphere. You know, in a sphere you need an axis. So we are going to call the vertical, this vertical line, the axis of our sphere. So it's going to be the axis of the celestial sphere, because now we are dealing with the celestial sphere. We're no longer dealing with the geographical sphere where she's standing on. We are now dealing with the celestial sphere that is all around Earth, that encompasses all astronomical objects. So it's going to be this imaginary sphere that is around it. That is all the stars that seem to be plastered on. It. You see, like this star, that nice star there, that is plastered on the sphere. So this is going to act as our axis in this vertical celestial system. So the vertical through the observer, so this is going to be through the observer, cuts the celestial sphere in opposite points called the zenith and the nadir. So now let's shrink this a bit. Imagine that the observer is here, and this is the extended line that the observer has made, and this, imagine that's the celestial sphere. So I've shrunk this diagram so that I do not show exactly what the observer is doing. The observer is now just a point. Imagine this is now the celestial sphere. If that is the celestial sphere, then this axis that I've created cuts the celestial sphere at 2 points, this point and this point. And since this is the axis, they are sort of poles. They are not exactly poles, but they are given special names. The one on top of the observer, this one on top of the observer, which is this one, is called the zenith. It's called the zenith. And the one below the observer, which is below the observer, is called the nadir, which is given an N as the symbol. So this one is the zenith and this one is the nadir. So that is the first part. That is the first part of defining this celestial system. Now we also know that there is going to be a plane which goes through this observer, which is perpendicular to this axis, because there's going to be what? A great circle that is perpendicular to this axis. Can you see that? Every axis has a great circle plane that is perpendicular to it. So we're going to have a plane that is going to be perpendicular, and it's going to pass through our observer. So that is one important thing. It's perpendicular to the axis. There's a circle here that's going to be perpendicular to the axis, but we want a circle that is perpendicular to the axis and also passing through our observer. If it's passing through our observer, we have a great circle. It's going to make a great circle. This one is not passing through our observer, so it's not going to be a great circle. This one is, so it's going to be a great circle passing through the observer. So the plane through the observer, which is perpendicular to the vertical, is called the horizontal plane. Thus, this plane cuts the celestial sphere in a great circle. This great circle known as the horizon. So can you see this? This great circle that is passing through the observer is called the horizon. And this horizon is just like what the layman says when you go out, they look out when you go outside, and then they say, the sun, look at the sun in the horizon. Or when you go to a game park and then you see zebras off in the horizon, you'll be talking about this, because that's what you are seeing level with you. Is the ground, all of the ground that is level with you, all the way up to the celestial equator. Anything that is level with your line of sight is your horizon. So whatever you see on the ground, and if you see maybe a star that is level with you without you lifting your head up to see the star, what I basically mean is, let's say you're on the ground like this, and this is your face. Let's say this is your face, and you are looking, and you're looking all the way, because the celestial sphere is like this, right? So there's going to be a star up here, but for you to see the star, you have to elevate. You have to elevate your line of sight for you to see the star. If there is a star like this, where you don't have to elevate, you just have to look, it is level with you. We call it, this star will be on your horizon, because it's on this great circle. It lies on this great circle that is what called the horizon. It lies on your horizon. So that is very important. So we are going to call this great circle is called the horizon. The horizon is going to be our x-coordinate. So now we have defined our x-coordinate as what? X-axis, not the x-coordinate. It's going to be the x-axis of our. It's going to be the x-axis. You remember on Earth, if you remember well, on Earth, our equator, our terrestrial equator was our x-axis. But in this vertical system, the x-axis is going to be the horizon. What you are seeing flat on the ground, all around you, the circle that is all around you, everything, if you look around, that is going to be the x-coordinate. That is going to be the what? The x-axis. So our x-axis is going to be the horizon. Hey, why am I saying the horizontal? It's going to be the horizon. Sorry for being so, I'm not being smart with this, but yeah, I hope you understand what I mean. This is going to be our horizon, isn't it? Now, when you look at this system, there are going to be great circles perpendicular to this horizon, just like in the terrestrial sphere when we had the meridians. There are going to be great circles perpendicular to the horizon. These are called vertical circles. Their planes contain the vertical axis, and they pass through the zenith and nadir. Just like on Earth, this will be the north geographical pole, and we'll be drawing those great circles that pass through, that pass like this, going all the way to the south. But in this system, we are not on Earth, we are in the sky. These are imaginary circles. We cannot see them. They are in the sky, but they link the zenith and the nadir, and they contain the axis, because it will be a great circle going all the way back, and its plane, when we cut the celestial sphere, will contain this axis that we have drawn, the vertical that we have drawn. So these ones here, these great circles that pass through the zenith and the nadir, are going to help us find our y coordinates. So now these ones in our vertical system, they are called vertical circles. In our terrestrial system, they were called meridians, but here they are called vertical circles because we are no longer on the terrestrial. The terrestrial will be somewhere there where the observer is, but now we're looking at the grand scheme of things, the outside world, everything. We are looking at the what? At the celestial sphere, the skies. We're looking at the skies. So these ones are lines in the skies. You cannot see them. They're imaginary lines in the skies, but this is their definition. They are great circles that encompass the vertical, and they are perpendicular to the plane of our horizon. They're perpendicular to the plane of our horizon. So now the origin, we are going to choose an origin because obviously we need an origin. Now we have our x-axis, and one of these is going to be our y-axis. So we need our what? We need our origin. The origin is chosen by making use of the fact that the Earth rotates about a fixed axis. You know, our Earth, when we drew our Earth was rotating about an axis that was linking the north geographical pole and the south geographical pole, and it was rotating about that pole. So this fact is, it does not change. The Earth always rotates about these two poles, about this axis that links the north geographical pole and the south geographical pole. This fact does not change, so we are going to make use of that unchanging fact. So if we extend this, because can you see, there will be the celestial sphere around the Earth. There will be a celestial sphere around the Earth. Let me draw it on down here. Let me draw it down here. This is going to be our Earth, and this is our north geographical pole on top here, and this is going to be our south geographical pole. And outside the Earth is our imaginary sphere that we call the celestial sphere, that houses all the astronomical objects. All the stars appear to be plastered on this celestial sphere somewhere, somehow. They appear to be plastered on that celestial sphere. So can you see this axis? If we extend it all the way to the radius of the what? Or to the circumference of the celestial sphere, we can extend it to the what? To touch the celestial sphere. It's going to cut the celestial sphere at this point and cut the celestial sphere at that point. So now when we extend it, it's going to cut it's going to intersect the celestial sphere in two fixed points. They are fixed because the north geographical point will not move, will never move. There's no way the North Pole, okay, unless when they talk about 2012, the effects of whatever, you know that movie, they were saying the North geographical pole is going to move, and let's get rid of all those complications. The Earth's North geographical pole will be at the same point, because it's just the Earth, it's rigid like that, and our south geographical pole is just going to be at the same point. So whatever we are going to extend there, it's just going to touch the same point, and there is going to remain fixed to the same point. It's going to touch the same point. So now the extended axis is called the celestial axis. So now this is now our celestial axis. It's called the celestial axis. This celestial axis is different from this vertical line that we drew here, because this vertical line depends on the what? On the observer. The observer will always extend it to be where he or she is. They will always extend it vertically like this. But if this person is not standing on if the person is standing on the geographical pole, then well and fine, because they're going to extend it their vertical the same way. But if they're standing at the equator, like at this point, their vertical will be like this. It is totally different from the what? The celestial axis. The celestial axis is fixed because it's in line with a fixed axis of the Earth. So this celestial axis is fixed. We are going to keep talking about this celestial axis as a fixed axis. So if you are at the poles of the Earth, celestial axis will be equal to the vertical axis, just like I explained. Because when you're standing here, your vertical will be like this. You're going to hold your vertical like this, and it will coincide with this celestial axis. This celestial axis cuts the celestial sphere at the north and south celestial poles. So on top of the north geographical pole, we are going to have our north celestial pole. We are going to have our north celestial pole. And for us not to confuse, let me remove this x-axis, because we haven't really defined our system. We are going to come back and define our system of measurement. So this one is going to be our north celestial pole, and down here is going to be our south celestial pole. So this celestial axis cuts the celestial sphere, because this is going to be our celestial sphere. It's going to be our celestial sphere. It cuts the celestial sphere at this point here called the north celestial pole and the south celestial pole. All you have to know is the north celestial pole is always above the north geographical pole, and the south celestial pole is always below the south geographical pole. As you can see, I think that makes sense when you think that these are coming from the extension of the terrestrial axis. So now the vertical through the celestial poles, we're going to draw the vertical circle through these celestial poles. The vertical circle through the celestial poles, the zenith and the nadir, is the observer's celestial meridian. This is now a bit interesting, because now I do not want to put the observer. I don't want to put the observer at the north celestial at the north geographical pole. Let's put the observer here. Let's imagine that this observer is here. According to that observer, her vertical will be something like this. Her vertical will be like this. So she's going to extend her axis to be like this. That's the way she's going to extend her axis. And you know, the vertical axis cuts at the zenith and the nadir. That's what you know. It's going to cut the celestial sphere at the zenith and the nadir. But this is a fixed axis called the celestial axis, and this one here is called. This one here, it depends on the what? It depends on the observer, and it's called the vertical axis, because it's coming from a vertical plumb line that the observer has let down. So this is going to be the vertical axis. So this is going to be the zenith, and this is going to be the nadir. So now there's a point that the meridian, or the great circle, or the circle that passes through the north celestial pole, the zenith, the south celestial pole, and the nadir, is called a celestial meridian. It's called the celestial meridian. So here, when I was drawing the celestial sphere, I was actually drawing the celestial meridian. So that is going to be the celestial meridian, because it is the circle that passes through our north celestial pole, our zenith, and it's going to pass through our south celestial pole and our nadir. So that outside circle there is what is defined as the celestial meridian. It is a vertical circle through the NCP, SCP, zenith, and nadir. It's called the observer's celestial meridian. It's given the name observer because it depends on the observer. If the observer is not here, is somewhere else, they will have their own celestial meridian. It depends on the what? On where the observer is, or it depends on the observer, because it is dependent on the definition of this vertical axis. The vertical axis depending on how the observer has created their plumb line and how they have created their vertical axis. So this is going to be our celestial meridian. So our celestial meridian is going to be our y coordinate of this system that we are developing. So I think in the next video we are going to develop this system and see how the coordinates are defined. This was just a theory of coming up with the system. In the next video we are going to see the angles being defined and how to use them. So stay tuned for that one.